Hey folks, in this lab I'm going to show you an easy way to do a Kruskal-Wallis test using the ANOVA template. You'll find the ANOVA template in the supplementary files folder. Now we're using the data here called the Business Admin 111 survey data, and this is an example of a bad survey. And so we've talked about this before. There's a bunch of videos called data cleaning, which you're going to find in the lab video section here. But I've cleaned up that data, so it's right here. And let's take a look at a couple of variables here. I'm going to, first of all, make a copy of this because you never work on the original data set. So I've made a copy now. And let's see, what are the two that I want to look at? I want to look at gender and movie ratings. So I'm going to get rid of anything that's not gender or movie ratings. I always keep the respondent column, and that's because we'll find that there's some missing observations in one or both of those columns there. And so the nice thing about the respondent is that there is a respondent number for everybody. So what I've got, what I've got here, there we go. Okay. So what I've got here then is the respondent column. Everybody has a respondent number, so we know that there's no blanks or gaps there. And then I've got the gender and the movie ratings. Now, gender is a nominal variable, and movies is a rating variable. So this was rating the movies on a scale of 1 to 10. Nominal versus ordinal, which is a rating variable. Nominal versus ordinal is a Kruskal-Wallis test. And so what I'm going to do is just clean this up a little bit here. I'm going to sort according to gender. You'll notice that I've got one row here which is colored orange, and that's just to make sure that when I do the sorting that they stay together, because you need to sort the movies with the gender and vice versa. So what I do is I click anywhere in gender and I go to data and then A to Z sort, and you can see it starts with the females. I go down here, males, and down at the very bottom I've got an N here, and the N actually stands for neither, which is a valid response here. But for Kruskal-Wallis, you need at least 5 in a particular category. So we'll just have to take that out. And then in the write-up, what you would do is you would say that there was one person who selected N for their gender. Let's go to the movie ratings, and I'm also going to do a sort there. And it looks like there's no holes here. There's no empty cells or anything. They go from 1 to 10. If you go all the way up here, you'll see that, in fact, we do have 1 to 10s here. Okay, so we are good. And notice that when we did the sorting that these guys stayed together. So the movies sorted with the gender. Next thing that we do is we want to unstack the movies according to the 2 classifications of the genders. So you click on the nominal variable, the gender variable, anywhere in there. So just a single cell, and we're going to go to data sort, A to Z, and then we go up to the very top here and we put in F and M. So those are the 2 genders that we have here. Then what we're going to do is we're going to copy the movie ratings that correspond to the females. So these movie ratings here, we're going to copy those over right there. Make sure that you don't paste right there, because you notice that I'm actually on row 17 here. So I click on the 17 on the F at the very top here, and then just use the down arrow. I could use the down arrow. Sometimes it goes a little goofy. There we go. Make sure that you're at row 2 here, and then paste them. And then I'm going to go down here and grab the males. Okay, so here's the males here. Yeah, so we're going to take the movie ratings for the males. All right, and I'm going to copy those, and I'm going to go up to the top here and paste them. Now, there's probably a different number of females than males. Looks like we've got a few more males in this class, or these. There's actually 3 sections put together here. So there we go. Now, then what we do is we copy these guys. Now, incidentally, we can't do this as an ANOVA because these data here are ordinal. And so it's nominal versus ordinal. ANOVA is when you have nominal versus interval. Having said that, we're going to actually still use the ANOVA template, which I introduced to you in another video on how to do the ANOVA test. So we're going to highlight these 2 columns, including the titles at the top, so the F and the M, and then all the way down to the end of the longest column. I'm going to copy that, and then I've opened up here this file called ANOVA-Template, and it's in your supplementary files folder. Now, although we'll be using the Kruskal-Wallis test here, the Kruskal-Wallis test here is a page you can't actually paste anything on. You can't move, you can't touch anything on here. The only thing you can do is copy and paste it into, say, a Word document. So what you need to do is still go back to the ANOVA one-way page and click on the yellow cell, or the orange cell here, where it says treatments. And then I'm going to right-click, choose Paste Special, and choose Values. You'll also find that at the top there under Home, and there's that paste with a little arrow next to it. And there we go. So we end up then with the F and the M ratings for the movies. Now, the important thing to note here is that you completely ignore the ANOVA page now. It was just used to input the values. And you turn to the Kruskal-Wallis page, and there's your results. You don't need to worry about normality, because normality is only when you're dealing with interval variables. You don't need to worry about the homogeneity of variances like you would in ANOVA. All you do is you go straight to the Kruskal-Wallis. And I would grab the Kruskal-Wallis data here. And I'd only take up to here. So the treatments with their names F and M, female and male, don't include any of these guys below, because you could actually have dozens and dozens of rows here. And I'm just going to copy that, and then I'm going to move over here to a blank page then. And you'd set up your problem here with you'd put down the question numbers and so on. And then I'm going to just go here and change the subscripts. So I've got the median of the females is equal to the median of the males. And then I don't need any of this stuff here. And those, I guess I can make those subscripts there. And it's kind of goofy to say as an alternative hypothesis that at least one of the medians differs, because when you're only dealing with 2, then it's just that they are not equal to each other. If it was 3 or more categories, you could certainly use a Kruskal-Wallis test where you've got 3 or more treatments. Then you would leave the HA the way that it was, which is that at least one of the medians differs. But because there's just 2, we would say that the median of the females equals the median of the males, versus the alternative that they're not equal. And you might need to clean this up a little bit here in terms of just the width of these columns and so on, like that, right there. And what we've got here is you always want to take a look then at the adjusted values here. So this is adjustment for ties. In class, this is what we get when we do this by hand, but there is an adjustment that tends to happen. It looks like there's not much of a difference here, But what we end up with is a really high p-value, which says that we do not reject HO. If you take a look down here, you see that the medians are the same. There are 7s. So the movie ratings are not significantly different between the males and the females here. Now, incidentally, just a point here, and that is that you can end up with rejecting HO, but the medians are the same. And that can happen if you, the middle numbers might be 7s, but then you've got it, maybe a whole bunch of high values for one of them and a whole bunch of low values for another one. And so the rest of the numbers around the 7s can be a lot different here. So it's kind of the difference between a high 7 and a low 7 in a sense. And so if that were the case, if you ended up rejecting HO and the medians actually showed the same, you would go here and you would see differences. And so in that particular case, you would say, well, this 41 is higher than the 40. Now, in our case, it's not. I mean, this is a very high p-value, so there is really no difference between these two at all. Okay, but if you did reject HO, the medians were the same, then you'd look here and find out which are the higher numbers. So that's how you do a Kruskal-Wallis test using this little template here, the ANOVA template. And that's where I'm going to end the lesson for this one. Thanks for watching.